Okay, so this is 11.6, which is just surface area of spheres. It also includes volume of spheres, but we do that separately. So a sphere is basically like a three-dimensional circle. Every point is equidistant from what we call the center, and it still has a radius, but the radius can go any direction. So there's an infinite number of them. Now, any circle that has the same radius as the sphere is called the great circle. So there's several that you can draw. Think of it like if you cut the Earth at the equator, the radius would be the same. Now you can't, cut it right here because that's a different radius. But you could cut it, going this way. If I can, well, that's not perfect, but you can cut it several different ways. So there's lots of great circles. When you cut it in half, they're called hemispheres, just like we call the Earth hemispheres. All right, so here are your two areas, and today, or your two formulas, sorry. And today we're just doing surface area, which is 4 pi r squared. So this says find the surface area of the sphere below. Show your answer in terms of pi. So surface area is 4 pi r squared. So r is obviously the radius, so we have 8 squared. So what I would do first, I'm going to write this out even though I don't expect you to, is I would square the 8 to get 64. Then I would do 64 times 4, which is 256. So you get 256 pi. Because it says in terms of pi, we don't actually multiply the pi. All right, this is a you try, so I'm going to pause it. Well, I want you to pause it and try it. I'll go ahead and work it out. So 4 pi r squared. Now here's the deal. It is 24 is the diameter. So the radius is 12. So you should be doing 4 pi 12 squared. 12 squared is 144. So it's basically 144 times 4, which is 576. So we have 576 pi. Hope that's what you got. And if you didn't get that, it's probably just because you used 24 for the radius instead of the diameter. All right, this is also a you try, so if you want to pause this and then I'll work it out and you can check your answer. So find the circumference of a sphere with a surface area of 100 pi. So surface area is 4 pi r squared. And I know it's silly to you to write the formula every time, but it's always going to get you extra points. And it's hard to mess it up if you have the right formula written down. Not impossible, but more difficult. So we have 100 pi for the surface area. So I'm going to plug 100 pi, 100 pi in for surface area and leave 4 pi r squared. I'm going to do this in separate steps just because it's easier for some people to see. You could divide by 4 pi all in one step if you would like. I'm going to start by dividing by 4. So I have 25 pi equals pi r squared. Then I'm going to divide by pi, and it actually cancels out. So now we have 25 equals r squared. Then take the square root. We get the radius of our circle, or our sphere, sorry, is 5. So it says to find the circumference of a sphere. So it's basically the circumference of the great circle. Circumference is 2 pi r. So I'm guessing we just leave this in terms of pi since it doesn't say to round it. So just plug in 5, so we get 10 pi. And if you actually multiplied it out because you weren't sure, it would be 31.42 or something like that. All right, find the surface area of the hemisphere below. Show your answers in terms of pi. Now, here's the thing. Surface area is whatever's on the surface. So if we do half of a sphere, you're only counting all this. But once we cut it in half, we now have all of this on the surface as well. So half of, let me write our actual formula up here. It's 4 pi r squared. Excuse me. So half of that would be just 2 pi r squared. But we've added this circle, which we now have to find the area for. So we have to add the area of that circle, which is just pi r squared. So it's really like 3 pi r squared is what you do for a hemisphere. Now if it were volume, you could just cut it in half and it'd be easy, but unfortunately this is a little bit more complicated. However, this is on your formula chart, so it's not anything you have to memorize. So we just do 3 pi 15 squared. 3 pi 225 is 15 squared. And we get 675 pi. Now this is a U-try and it does give you the radius, so you might want to pause it and try it. It is surface area of a hemisphere, so it's 3 pi r squared. So 33 squared is 1,089. I'm going to go ahead and multiply that by 3 instead of writing it out. And that's 3,267 pi. Hopefully that's what you got. All right, this is also a U-try, so you may want to pause it. I'm going to go ahead and read it. The radius of the sphere shown was divided by 3. Describe the effect on surface area and volume. So we've talked about this a lot, this PAV 1, 2, 3. So when you change dimensions, the perimeter changes by the scale factor, area changes by the scale factor squared, and volume changes by the scale factor cubed. So if everything's divided by 3, that's kind of a tricky way to ask it, but the scale factor would be 1/3. So the surface area would change by a factor of 1/3 squared, which would be 1/9, and the volume would change by a scale factor of 1/3 cubed, which would be 1/27. Find the surface area of the composite figure shown. Show your answers in terms of pi. Now this is a cylinder and a hemisphere. Now you can't use, well, it depends on how you want to do it. The hemisphere is no longer showing this circle that we added on the other problem. Because it's covered up, the hemisphere is just going to be 2 pi r squared. And then I would do lateral surface area of the cylinder. I'm trying to remember what it has on your formula chart. I'm pretty sure that's the one where it does it for you. It's 2 pi RH plus 2 pi r squared. But that's the 2 pi r squared is counting both bases. So since they're not both showing, what I would do is just change this to pi r squared. Now if that's too much for you, you can do the entire hemisphere, the entire cylinder, and just subtract that circle twice because you've double counted it and it shouldn't be there at all. So we get 2 pi 6 squared plus 2 pi 6, 9 plus pi 6 squared. So we get 36 times 2, 72 pi. 6 times 9 is 54, times 2 is 108 pi. And then we get 36 pi for that last one. Now, these are like variables. It's like you're adding 72x plus 108x plus 36x. So you just add 72 plus 108 plus 36, and you get 216 pi for the whole thing.